how does something so universally pretty do so much damage?
You look at the horizon and see 3 suns in the sky. What's your first thought?
Did you know the auroras make a sound?
Have you ever looked up at the sky and genuinely felt like the simulation was breaking? Like somebody accidentally loaded the wrong graphics package for the atmosphere?
Absolutely. We're so used to the sky just being blue, maybe some fluffy white clouds, that when nature actually decides to flex, it looks completely unnatural. CGI in real life.
Welcome to the podcast. If you're listening to this, imagine you're sitting with us around a campfire, looking up at the stars. Because today, we are looking at 3 of the rarest, most visually insane sky phenomena on Earth.
And the crazy thing is, the science behind them is actually wilder and sometimes much darker than how they look. We're talking illusions that have altered the course of history, clouds that are secretly toxic, and peaceful lights that are actually masking violent cosmic warfare.
Let's start with one that literally makes you see double or triple. Alex, imagine we're sitting out here tomorrow morning at sunrise. You look at the horizon and see 3 suns in the sky. What's your first thought?
Honestly, I'm assuming the apocalypse has started, or my coffee was heavily spiked.
Which is exactly what people throughout history thought. We're talking about sundogs, scientifically known as parhelia. You look at the horizon during a freezing sunrise or sunset, and flanking the real sun on the left and right are 2 phantom suns. It looks like a glowing halo with 3 distinct blazing bright spots.
And what I love about this is that it's purely a massive atmospheric optical illusion. It's caused by millions of tiny mirrors falling through the sky. When the upper atmosphere gets extremely cold, water freezes into these perfect flat hexagonal ice crystals. They drift down flat, almost like microscopic plates or leaves falling from a tree.
Right, and because they are hexagonal, they act as perfect little prisms. When the sunlight hits them, it bends at exactly a 22-degree angle. So the extra suns you are seeing are just refracted light, concentrated in 2 spots. You are literally looking through a massive kaleidoscope made of ice.
But imagine seeing that before you had modern meteorology to explain it. During the Wars of the Roses in 1461, right before the Battle of Mortimer's Cross, the Yorkist army saw a sundog. The troops were terrified. They thought it was a demonic omen, like nature itself was telling them they were going to die, and they wanted to flee.
But their commander, Edward IV, was incredibly quick on his feet. He pointed at the sky and told them, No, you have it all wrong. Those 3 suns represent the Holy Trinity. God is literally on our side. They went into battle, won a crushing victory, and he actually put the sun with rays on his royal emblem.
A weather phenomenon literally changed the branding of the English monarchy. It changed the outcome of a war. And the crazy thing is, this doesn't just happen with the sun. Have you ever heard of moon dogs?
Wait, like phantom moons?
Yes, paraselene. If the moon is exceptionally bright, like a full moon on a freezing winter night, and those same ice crystals are in the air, you can get glowing phantom moons flanking the real moon. It is incredibly eerie to see in the pitch black.
I can only imagine the folklore that came from seeing 3 moons in the dead of winter. It's wild how an ice crystal can feel so magical. But as mind-bending as sun and moon dogs are, they are completely harmless. Our next phenomenon isn't.
Let's move way, way up into the stratosphere. Usually, clouds form pretty low to the ground, in the troposphere. But sometimes, in the extreme, brutal cold of the polar regions, you get nacreous clouds, or mother-of-pearl clouds.
They do not look like normal clouds. They look like glowing, iridescent oil slicks painted across the twilight sky. We are talking vivid neons. Pinks, greens, purples. They are arguably the most breathtaking things you can see in the sky.
They form at massive altitudes, around 50,000 to 80,000 feet up. Up there, it's incredibly dry, and temperatures drop below negative 108 degrees Fahrenheit. That's negative 78 Celsius. Because they are so incredibly high up, they catch the sunlight from over the horizon long after the sun is actually set for us on the ground. That's why they seem to glow in the dark against the black sky.
It sounds like a dream, but here is the massive YouTube plot twist. The beautiful but deadly angle. These clouds are actually aiding in the active destruction of our planet's ozone layer.
Yeah, it's the ultimate toxic trait. How does something so universally pretty do so much damage?
It comes down to chemistry and surface area. Remember back in the 80s and 90s when everyone was panicking about the hole in the ozone layer? We learned that human-made chemicals, CFCs from old hairsprays, aerosols, and refrigerators, had drifted up into the stratosphere.
Right. The stuff we eventually banned globally.
Exactly. But here is the kicker. On their own, those CFCs react incredibly slowly. But the ice crystals in nacreous clouds provide the perfect physical surface for a chemical reaction. They act as a catalyst. When those harmless-looking neon clouds form, they take benign chlorine compounds and turn them into highly reactive, ozone-destroying monsters.
So, when you are standing in Antarctica or northern Scandinavia, looking up at this breathtaking, glowing neon rainbow cloud, you aren't just looking at weather. You are actually watching a localized environmental disaster happening in real time.
It's a literal scar in the atmosphere catching the light. It's nature's prettiest, most glowing warning sign that we messed up.
Okay, speaking of the atmosphere protecting us, let's talk about the undisputed crown jewel of sky phenomena, the Aurora Borealis and Aurora Australis, the northern and southern lights.
Everyone has this on their bucket list. The idea of standing in the snow, watching these ethereal ribbons of green and purple dancing silently across the stars. It feels peaceful, almost spiritual.
But the science behind it is anything but peaceful. What you are actually witnessing is a violent cosmic war. You are seeing Earth's invisible deflector shields taking a direct hit from a solar laser beam.
Our sun is constantly blasting out what we call solar wind, this high-speed, chaotic stream of charged particles, electrons, and protons. If that wind hit the surface of the Earth directly, it would strip away our atmosphere over time, and we'd look exactly like Mars, just a dead, irradiated rock.
But thankfully, Earth has a massive, spinning core of molten iron, which creates a huge magnetic field. When those highly charged solar particles hit us, that magnetic field deflects them, funneling them away from the equator and dumping them toward the north and south poles.
And as those charged particles slam into the gases in our upper atmosphere at millions of miles an hour, they transfer all that energy. And that energy makes the gas glow. If the particles hit oxygen, you get that famous neon green color. If they hit nitrogen, you get blues and purples. You are basically looking at a massive fluorescent light bulb powered by a star happening 60 miles above your head.
And here is a crazy detail that people rarely talk about. Did you know the auroras make a sound?
Wait, really? I thought it was completely silent.
For decades, scientists told indigenous people and Arctic explorers they were crazy for claiming they could hear it, but researchers recently proved it's true. During strong auroras, people on the ground hear a strange crackling, hissing, or clapping sound. It happens when the electromagnetic disruption from the aurora discharges static electricity trapped in an inversion layer of cold air just a few hundred feet above the ground. It literally sounds like the sky is frying.
That is terrifying. And it gets scarier when the sun gets really angry. During a coronal mass ejection, a massive solar flare, these auroras can push way further south. Which brings us to the Carrington event of 1859.
Right. This is where the pretty lights become a global threat. In 1859, the sun hit us with a solar storm so massive that the northern lights were seen as far south as Colombia and Hawaii. It was so bright in the middle of the night that birds started singing, thinking it was dawn. People in the northeastern U.S. were reading newspapers outside at 2 a.m. by the light of the aurora.
But the crazy part? The electrical charge in the atmosphere was so intense that telegraph systems, the Victorian version of the internet, went completely rogue. Telegraph operators were getting physically shocked by their machines. The paper printouts were literally catching fire. Some operators unplugged the batteries completely, and the machines kept sending messages, powered entirely by the raw energy pulling from the aurora in the sky.
Which begs the ultimate terrifying question. What happens if an aurora that strong hits us today? We don't rely on telegraphs anymore. We rely on a fragile global power grid, thousands of satellites, undersea internet cables, and cell phones.
Scientists call it the Internet Apocalypse scenario. If a Carrington-level storm hits us today, it wouldn't just be a pretty light show. It could blow out transformers globally, knocking out power and internet for months, if not years. It would be a multi-trillion-dollar disaster. It just goes to show, nature's most beautiful phenomena are usually a stark reminder of how incredibly fragile our little bubble of a planet really is.
So the next time you look up and see 3 suns blazing on the horizon, a glowing neon cloud in the pitch black, or a ribbon of green light hissing in the sky, just remember, the sky isn't glitching. It's just showing you the chaotic, violent physics engine that runs our world.
And frankly, I prefer the chaotic physics over a boring blue sky any day, even if it might fry my Wi-Fi router.
If you guys want to see exactly what we've been talking about, check out the links in the description where we've linked some of our favorite footage of these phenomena.
And we'll catch you in the next episode.